Many body problems. What we mean by this is problems with more than one mass. What we said last year was these are questions where we have several masses connected together with strings. The easy approach is to realize all the objects are going to accelerate at the same rate. Sorry for those of you on YouTube, you can't see this. But what we said last year was if I have two objects accelerating, if one is accelerating up at 3 meters per second squared, the other mass is accelerating to the right or to the left at 3 meters per second squared. I already put the cube away. I want your full attention here. Okay. What we're not going to do is yank on the rope. That right there actually has a proper physics term. It's called a jerk. That's the actual term in physics, and no jerks in my classroom. Okay. So what did we do? Well, let's just jump on in. Kenta, example 1 says, find the acceleration and the string tensions. You know what this is a good job for? Let's do the free body diagram, you and I. I always start from the left and work my way right. So what are the forces acting on the 6 kilogram mass? Get the obvious one. Is there more than one mass? I'm going to call it M1G. What else? And is there, you know what? I'm going to call it normal force number 1 to go with mass number 1. What else? Yeah, there's a rope. And so we called the force from the rope tension. I often just put the arrow right on the rope because I'm not doing a proper, I'm doing a casual free body diagram. Is there friction in this case? If there was, I would have one more arrow pointing that way, but no problem. I think that's it. What are the forces acting on mass 2? Get the obvious one. More than one mass, I'll call it mass 2G. Keep going. Normal force number 2. What do I call that 40 Newton coming from off the page? Good. And I'm missing one. Yeah, because forces, this is a Newton's third law, forces come in pairs. Attention. Then what our strategy was, is we're going to write an equation along the rope or string. If this is going to accelerate at all, I think it's going to be accelerating to the right. So let's assume to the right is winning. Kenta, who's winning? And what you've really decided is anything pointing to the right is going to be winner plus. Anything pointing to the left is going to be loser minus. So this tension right here, winner plus or loser minus? What about the next tension? What's that going to equal? What was the tweak that we did? We said last year, Ella, because I have forces from more than one mass on the left, I better have more than one mass on the right. We wrote M all times A. And then last year I made some dumb joke. I would have stretched. What was my indication for that? Yeah, we're losing tension. Some of you need to do that. And in fact, it wants me to find the acceleration. You know what? I think I can just go divide by, but instead of M all, I'll write M1 plus M2 because that's what M all actually means. I think, Kenta, we can start to plug in our numbers. A is going to be F applied 40 divided by 6 plus 4. Put your calculator down. In your head, without a calculator, Kenta, what's 6 plus 4? 10. What's 40 divided by 10? My goodness. Meters per second squared. Now, what we said last year, our strategy was if I want to find the acceleration of everything, I'll write an equation for everything. If I want to find an individual force, like tension, I'll write an equation for an individual mass. So, Kenta, to find tension, let's do an equation. So mass 1, I think I'll do it really quickly. We had M1G, we had normal force number 1, we had tension. Yes? Okay. Who's winning? Who's losing? It's a trick question. So what's that going to equal? Not M all A, because I'm only writing an equation for mass 1, it's going to be M1A. You know what? You might even be able to do this one in your head without a calculator as well. What's M1? What was A? Without a calculator. Look at you doing big boy math in your head. Ashley, what would be really neat is if it didn't matter which mass I picked. It would be neat if I found tension using mass 2, if I got the same answer, and then I could pick the easiest mass to work with. That would be lovely. Let's try for consistency. Let's check mass 2. So mass 2, we had M2G, normal force 2, F applied, and tension. Okay, Kenta, let's do this one together. Who's winning? Who's losing? There is a loser this time. That equals M2A, not M all A. I want to get the T by itself. Kenta, what's right in front of the T that I don't like? We called this the swappy dance. We're going to plus the T to that side. At the same time, we're going to minus the T to this side. And when we do that, we're going to get F applied minus M2A equal. You know what? Instead of equals T, I'm going to put the T equals on this side because that's where I'm used to seeing the thing by itself. You know what? You might even be able to do this one in your head as well. Let's see. It's going to be 40 minus 4 times 4. Without a calculator, does that also work out to 24? Oh, boy. So this was our strategy. Victor, we said last year, okay, you want me to find the acceleration of everything? I'll write an equation for everything, and the only tweak is it'll be winner minus loser equals M all A. Oh, you want me to find something about an individual mass, an individual force? I'll look at an individual mass. When we have several masses connected by strings, we need to realize that the first string, this one, accelerates the first mass, but the second string, this one, accelerates both masses. In fact, Eliana, we need to realize we're going to have 2 tensions. I'll call them tension 1 and tension 2. Eliana, what does example 2 want me to find? You know, this is a good job for? Let's do that. So it's going to be M1G. Keep going, Eliana. Slow down. Is there friction in this question? Really? How do you know? I gave you a mu. So which force am I missing? Okay, there's also going to be friction. I'm going to call it friction force number 1 to go with mass number. Okay. Yeah, those are the forces acting on mass 1. Now let's walk to mass 2. What are the forces acting on it? What else? Which way is tension 2 going to point? I can't hear it. Sorry, which way is tension 2 going to point? To the right, I agree. Because this is the second rope. This is pulling with tension 2. I'm missing a couple still. Tension 1, here's my Newton's third law, forces come in pairs consequence. Friction force number 2. I think that's everything. Now let's go to mass 3. Go ahead. What else? We have good old F applied. Which tension? Tension 2. And, okay. Who's winning? I think the 20. How would I know if the 20 wasn't winning? How would I know if we were slowing down? If I assume we're speeding up and I get a negative acceleration, it tells me I picked the wrong winner. All right. Whew. I've scrolled all the way down. So what's my equation? Walk along the rope. Start with F applied. Yep. You'll have to look at your free body diagram because I've scrolled. Did you get it all copied? Ah, of course, you could just redo it from scratch. I stopped listening. Got them all? I'm waiting just for you. Oh, sorry. Because I can't, unfortunately, fit this whole thing on one page. Okay. Who's winning? Walk along the rope. Then what? I think we have minus tension 2, yes? Minus friction force 3. And then plus tension 2. Minus, isn't it minus tension 1? And then plus tension 1. Minus, did we miss any? What's that going to equal? M all A. Oh, this is a double dose. Really losing some tension. This is great. Gone, 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 gone. And in fact, Eliana, I'm going to do one more thing because I know I'm trying to find A. I'm going to cross out the M all and I'm going to say, hey, it's going to be M1 plus M2 plus M3. I think I've got to move down a line. Let's see. So A equals F applied minus friction 3. I'm not going to write friction 3 because friction is what times what. So it's going to be mu times normal force number 3. I don't know normal force number 3. Oh, but look, 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 look. I don't know the force the same size as normal force number 3. Which one? Which mg? This is normal force number 3. What? This is why, number them. It takes 1 second. So you know what? I'm going to cross this out right here, and I'm going to say M3G. I've showed my work. In fact, some of you might be comfortable enough to have gone straight to the M3G on this one step, and if you could, Aryan, I'd be fine with that. And then I have minus friction force number 2, which is going to be mu times normal force number 2. I don't know normal force number 2. Oh, but look, 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 look. It's going to be M2G. Yes? Minus, and I think it's going to be mu M1G all over M1 plus M2 plus M3. All righty. Can you tell me my numbers, Eliana? F applied was 20, wasn't it? And then minus 0.2. What was M3? Sorry? I don't think M3 can be 3. 5? 9.8 minus 0.2. What was M2? And M1, there I have it on my page, 0.2 times 3 times 9.8 all over 3 plus 2 plus 5. Do this one in your head, Mr. Actually, I might be able to. I'm dividing by 10. Let's try. Oh, yeah, 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 yeah. This is going to be 10 times 9 point. It's going to be 98 times 0.2. So it's going to be 9.8 times 2. It's going to be 19.6. It's going to be 20, take away 19.6. The top is 0.4. Is it 0.4 divided by 10? Is it 0.04? Ooh. Seconds squared. That was easier than I thought it would be because on the bottom was a 10 and on the top the 5 and the 2 and the 3 were a 10. I kind of cheated and did some factoring in my head. Is that a big acceleration, Eric? This is almost at rest. Barely accelerating at all. Okay. That's A. Ooh. Kyle, what did B want me to find? Which mass would you use to find tension 1? You know what? Even more basic. Which mass would you try and stay away from no matter what if you could? Look at your free body diagram. Sorry? Mass 3? Which one is way more cluttered? Which one am I going to try and stay away from? Same answer. Yeah. I'll use mass 1 to find T1. I think I'll use mass 3 to find T2. So what's my equation for T1? Let's see. Which way is mass 1 accelerating? I'm going to go back here so you can look at my free body diagram. You know what? I think it's going to be tension 1 minus friction 1. Yes? Tension, I'll put a little letter B here. 1 minus friction 1 equals what, Kyle? M1A. How would I get the T by itself? How do I get the T by itself? Don't overcomplicate it. How will I move that over? Yeah. It's not, this is point being, this is not a swappy dance. This is the other one. We're just going to plus the friction 1 over. Tension is going to be M1A plus, you know what? Instead of friction force number 1, I think I can write mu M1G. Okay. Tension is going to be, what was M1? 3? A was 0.04 plus 0.2 times 3 times 9.8. Did that one in your head, Mr. Well, maybe. Yuck. 3 times 9.8. I don't have a good trick for that. Well, I can factor a 3. Yeah. Oh, no. Hang on. Not too bad. 19.6. No, never mind. Don't have a good answer for that one. Ruby, what'd you get? Even? Oh, I should have been able to do that one in my head. If it works out even, there's no excuse. All right. Which mass am I going to use? I know it says consistency check. I need to move these diagrams around. Let's do mass. Let's do tension 2. Kyle, write me an equation for mass 3. I'll scroll back. By the way, my new pen doesn't write as nice as my old one, so amazingly, I'm going to be even messier. Sorry. F applied minus tension 2, minus friction 3 equals M3A. I think that's what we're going to have. So it's going to be F applied minus tension 2 minus friction 3. That equals M3A. Kyle, how would I get the tension? Oh, what's right in front of the tension 2 that I don't like? This is going to be a swappy dance. I'm going to plus that there, and then Marcus, I'm going to minus that there. I'm going to get F applied minus M3 3A minus friction force 3. And then Kyle, if you don't mind, I'm going to put the tension 2 there because that's where we're used to seeing the thing by itself. All right, let's try plugging in numbers, Mr. Dueck. Tension 2 equals, what was F applied? Oh, 20. I have the numbers right there. Minus M3, 5. A was 0.04. Minus mu times M3. Gee, I couldn't get the 6 in my head. Maybe I can get this one in my head. It's not too hideous, Mr. Dueck. 2 times 9.8 is 19, 0.2 times 9, it's 1.9. Oh, yeah. Yeah. 10. Yes? Carried a decimal wrong earlier. That's why I thought it was so tough. Dull. It's my 10 times table. Only an idiot would need their calculator, need their 10 times table, right? Right. Is that right? Okay. So I don't know if I'm going to give you, in fact, I know. I'm not going to give you a 3-mass question on your test. Maybe on a quiz because you got more time because you're doing it at home. And in your homework, sure. But on the test, 3 masses, you could handle 5 masses. It's doable. It's just so much writing. You could handle 10 masses. It's doable. So much writing. What if we have a hanging mass? We need to understand that it's the weight. When I say the word weight, which force am I talking about? Nope. Okay? It's the mg that's causing it to accelerate. In other words, if I do a quick free body diagram here, I would have m1a, m1g, sorry, normal force number 1. Kenta, I would have tension. I would have friction 1, m2g, and tension. What force is causing this whole thing to slide? What's starting this little chain reaction? That there. If anything is winning, that's probably my winner. But I notice example 3 and example 4 are nearly identical. I'm going to take a bit of a gamble. I'm going to skip example 3. I'm going to see if I can go straight to example 4. So let's see if we can handle this. Arian, what does part A want me to find? What does B want me to find? What's this a good job for? Help them out, folks. What's this a good job for? What? You better be getting that one, okay? You ready, Arian? Let's do the 12 first. What are the forces acting on the 12? Get the obvious one. Is there more than one mass? I'm going to call it M1G. What else? Good. I'm going to call it normal force number 1 to go with mass number 1. What else? Which way? What else? What else? Good. I was hoping you'd have enough conviction to say that's it. What are the forces acting on the second mass? Get the obvious one. Is the 4 kilogram mass sitting on a surface? Be obvious. No, is there a normal force then? No. Kids get normal force loopy in grade 11, especially. It starts sticking it everywhere. No, if you're not on a surface and it's not leaning against the wall, I've made a gap there, so there's no normal force from the wall. What else? Yep. Okay. A says find the acceleration. Again, I'm going to walk along the rope, but this time, because there's a pulley, the rope is going to do, Dean, a 90-degree bend. So I'll do a 90-degree bend. Aryan, who do you think is winning? Well, Friction isn't going to magically cause this to start crawling left and up. Let's assume that down on the right-hand side is winner, and let's write an equation for that. So anything that ends up pointing down once it gets to the right is going to be a winner plus. Give me my equation. Walk along the rope. I'll give you a hint. It's going to start with M2G. Good. 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 Do I need to include M1G? Don't I need to go minus M1G? Or do I? Is M1G along the rope? No, this was by far the most common mistake. I gave this question, I think, last year in Physics 11, and I had a bunch of kids, don't write this down, don't write this down. They did that, and I hammered them for that. It's not along the rope. No, 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 no. You're correct, Aryan. We're done. So what's it going to equal? What does winner minus loser always equal? Is there more than one? Yeah, this time I got forces from more than one mass. I better use more than one mass. Aryan, you need to lose some tension. Stretch it out. You've earned it. Come on, put your head down. Stretch it out. You've earned it. Oh, and since we're trying to find A, do you mind? I'm going to go like this right away, Aryan. Let's see what we get. We're going to get A equals M2 4 G 9.8 minus friction is mu times the normal force. You know what? It's going to be mu mg in this case. It's going to be 0.4 times 12 times 9.8 all over 4 plus 12, or 12 plus 4. I think you're going to get, I'm doing some quick math in my head, a little bit of a weird answer here. Aryan, let me know what you get. You should get, are you getting an answer that's a little odd? Yes? I'm not saying what it is, but you should be going, huh. Aryan, what'd you get? This is why you practice on your calculator to get faster. No, not a chance. First of all, there's a built-in error check. If I cut the rope, what's the fastest this can possibly be accelerating at? So to say 33 points, not a chance. Did you put the bottom in brackets, Aryan? So let's type it in, Aryan. You ready? Is this a fraction? Oh, he's not even listening. The rest of you got a negative, yes? Negative what? 0.49? So what does that mean? Let me type this into my calculator. So if I go bracket 4 times 9.8 minus 0.4 times 12 times 9.8, close off the top, divided by bracket 4 plus 12, and I get negative 0.49. I picked the wrong winner. You know who is winning? Friction. But it's an easy fix. Everybody look up and keep looking up for a little bit. It's an easy fix. Watch. I'll do the fix in red. Keep looking up when I say keep looking up. I'm looking at you now. Yes? Here we go. In red. That's a winner. That's a loser. That's a winner. That's a loser. That's a winner. Insert. That's a loser. It's a pretty quick fix. Now, in this case, you still get 0.49, but positive. For a more complicated question, you might have had to change one more thing. You might have had to flip friction around if you had it sliding the wrong way. We'll get to those. But my point is, if you get a negative acceleration, don't just say, oh, the answer is positive. It might not be. But it's a pretty easy fix, and it's telling you picked the wrong winner. What's happening here? Friction is so big, this object, instead of speeding up, it's slowing down, and it's going to come to a stop. So I'm going to say, okay, 0.49 meters per second squared. But if you want me to give a direction, left and up, it's slowing down. Doesn't mean it's moving to the left. There's nothing that will cause a box to spontaneously start to crawl in that direction. What it does mean is, hey, this object is slowing down. Which mass would we use to find tension? It's pretty obvious. What mass would you use to find tension, Eric? M1 or M2? Why? Less stuff, yeah, less cluttered. So let's find tension using M2. It's going to be M2, we'll call that part B, M2G minus tension equals M2A. Swappy dance. M2G minus M2A. That equals tension. What was M2? Eric, I've scrolled down. What was it? G, 9.8 minus 4 times 0.49. 37.2? Or am I wrong? Yeah? And Aryan, you figured out where you zigged earlier? Brackets? This is why you want to type along all the time, right? Right. Last one. I wanted to try and give you some time to work on this and get caught up. Ooh! Ella, what's example 5 asking me to find? Hey, what's mu? I don't know. What's mu with you? Okay. What might this be a good job for? Alrighty. What are the forces acting on it? Okay, let's do M1. It's going to be M1G, normal force 1, tension. Ooh, and don't forget friction, right, Ella? I'll call it friction force number 1 to go with mass number 1. What are the forces acting on mass 2? M2G and? Okay. I've realized this question is poorly worded. Really, it should say accelerate to the right. I'm making you assume that. I would never let this get on a test. I would have caught that, and I would have said, well, we just had, by the way, what direction were things accelerating here? To the left and up. Here, we're accelerating right and down. Okay? So, Ella, what's my equation? Who's winning? Keep going. Equals? How's your day going, Ella? Lose some tension. Feel a little better. What's this question asking me to find? What is the mu hidden inside of? Let's get friction by itself. What's right in front of friction that I don't like? Swappy dance time. And you know what? Instead of equals friction force number 1, I'm going to write equals mu times normal force number 1. I think I can do that in the same step without losing you folks. Ella, how would I get the mu by itself? Yeah, except I don't know the normal force. Oh, but look. I know the force the same size as the normal force. Yes. So mu is going to be M24, G 9.8, minus, I guess in brackets, 2 plus 4 times 5.5, all divided by M12, G 9.8. I'm hoping we get a mu between 0 and 1. I made up numbers, but I hope these are good. Throw this one in your head, Mr. Dueck. Ew, that 5.5 is yucky. 6 times 5.5, well, 6 times 5 is 30, so it's going to be 30 plus 3, so it's going to be 33. It's going to be 4 times 9.8. What's that, Mr. Dueck? It's going to be 19.6 plus 2, so it's going to be 39.2 minus, what did I say? 30. Never mind, it's not going to work out nice. It's going to be a yucky decimal. I can tell you it's going to be in the 0.3-ish range, but I can't get much more than that. I hope. Ella, you ready? Here comes the pressure. What'd you get? Oh. And if you're getting the wrong answer, now's the chance to ask me to look at your calculator. I think to type this one in, it's going to be bracket 4 times 9.8 minus another bracket, 2 plus 4, close off that, times 5.5, close off the top, divided by bracket 2 times 9.8, because there's also more than one thing on the bottom. Did you get 0.31632? That? 0.316 units. Oh, there is none. There is none. Okay. What's your homework? I'll show you what I gave my Block F class this morning. Where were we, Mr. Dueck? Many body problems. I kind of cut things back a little bit, but number one, if you have trouble with number 1, 2 and 3 are identical. You can do those, but only if you feel you need the practice or for your studying later. I skipped number 4 because it had no friction. I skipped number 5 because it had no friction. I thought too easy. I did do 6. 5 and 6 are identical, so there's one with no friction. Number 7, here's one with friction. Number 8, here's one, a mass hanging over a cliff with friction. Then I skipped 9, or as I like to say, I said 9. I skipped 10. 11, here's a 3-mass question with friction. I skipped 12. 13, you can put a star next to. We actually did this one last year, but you might see if you can figure out or remember how to do it. I skipped 14. 15, you can put a star next to. This is a missing mass question, which we haven't done yet. That's going to be tomorrow, Friday's lesson. Okay? You also have homework from all your other lessons that you can do and catch up on.